Welcome back to another Sunn Day Service. Today we're jumping back into my Sunn Model T, and we are going to be replacing all of the electrolytic caps. These guys are 21 years old, and so is the big filter can cap. They were replaced in 2003, so coming up on 22 years. We'll also be getting the small signal caps that are in place here. The tube sockets, though, we're going to save for another video. That's going to be a whole job in and of itself. So let's go ahead and dive in, get these filter caps replaced, and I'll show you how we do that. Okay, so we're going to start off by replacing these two caps in the preamp. This guy's a 220 microfarad at 25 volts. This one is a 10 microfarad at 100 volts. And we're just going to throw new caps in there just because, since we're in here. So I'll start by desoldering these connections. This guy, it looks like the leg goes through between 2 points on the tube socket. So we might end up clipping that leg and then desoldering it separately, but we'll see how it goes here. Okay, so we've got this guy out. You can see this is the positive side. The negative leg is being pointed to the other side. That's what that is there. A little minus sign pointing towards this side. There's also a little indent right here. I'm not sure if that's making it onto the screen, but that indicates the positive side of an electrolytic. So now we will clean solder out of those 2 points to ensure we have a nice clean connection point.
Now we can pull this other leg out. Clean that point as well.
Okay, so let's take a closer look at what that now looks like. So you can see we have enough space here to now connect the negative side. Positive side is going to go through, let's see, right here. Oh, you don't want that. And then it's going to continue through to the other side of the socket here. And that's where we just disconnected from. So now we'll get the new capacitor in place. You can actually see there's quite a bit of a size difference. And that's just a matter of improvements in construction for electrolytic caps. We're putting in a new Vichy capacitor. Okay, so we have a relatively good mechanical connection there. And our polarity is correct. You can see it's relatively stable even without any solder, which is what we want. Let's go ahead and solder this in place. Okay, so next up is going to be this one over here. And again, we're putting in quite a smaller electrolytic. Let's go ahead and do the same thing for that guy. Okay, so you might be able to see that, but this guy actually has a hook that went around, so it's actually easier in this case to push it forward, clip this hook side, and now we can easily remove this. And again, the negative is pointing towards this leg, so this will be our positive side. And you can see this resistor was just barely holding on to that connection. I don't think it's going through the eyelet at all. So we may fix that. Okay. Let's go ahead and pull the excess solder out of there. Okay, now without that excessive solder in place, we should have room for this resistor to actually go through the eyelet instead of sitting on top like it was before. Let's clean the solder out of that top eyelet though, so we can get the cap in place. And again, we can see the size comparison between the parts we're replacing. Another Vichet cap going in, replacing this Jamicon that was in there originally. And we just want to make sure the polarity is correct. Get just enough of a mechanical connection. That it's easy to replace if we need to. So that it's also secure. The thing you don't want to do is wrap the leg all the way around or something like that. It's really tricky to desolder components that are done that way. So you're basically just making it harder for the next technician, and it doesn't really add any benefit. But a good half wrap is a good way to go. Since you then have a mechanical connection, but it's also serviceable in the field if needed. And we gotta get that first guy with a little bit of a touch up. Okay, I think that'll be good. We'll go ahead and clip our excess leg. That guy's nice and solid. This isn't a heavy enough cap Neither of these are big enough that we really have to worry about them being supported by their own legs. Okay, let's move over to the filter caps. All right, now we actually already redid the bias caps before finding the initial problem with the tube socket here. So we're gonna have to redo some of this work when we replace the tube socket. It's not too big of a deal. But today we will be replacing these big giant guys, and then also the one that's hiding on the other side there that I'll point out for you. We'll flip over the amp so you can get a closer look at that as well. Let's do these first. You can see here, there's an 03 on the front end of the serial code. That indicates that this is an 03 capacitor, 2003. But these guys are 20 microfarad, 600 volts DC each. And really, that's kind of the only game in town for the replacement, are the Sprague Atom style. These are about 30 bucks each. Now, there are other ways you could do this on a budget. You could easily do like 240s in series to get that, split this voltage. It's the 600 volts that's hard to find in a capacitor in this style. So you could do a combination of caps to get that same thing. Now, if you do that, you may want to have resistors in parallel with the capacitors like you see in other amplifiers that do a similar setup. So I'm not going to speak to that in detail here. I'm just saying that there are other options to explore if you do not want to go this route. That being said, this is a very expensive rare amp. It deserves to have the right parts for the job put in place. Okay, so otherwise, this will be pretty similar to the work we just did. Desolder, remove. I'll probably remove both caps and then put the new ones in at the same time. Here we go. Okay, both of the large electrolytic caps are out. I'm going to do some work cleaning up this space. It's pretty tight in there, so I don't know how much of this you're going to even be able to see with my hands in place, but need to clean up the solder for these 2 points. As well as over here, it looks like the negative for both sides basically connect together, which then connect to these 2 wires via this terminal strip. The positives each go to their own wire. That's the red and white stripe here on this side. And then they have these nice clips in place to help hold everything in place, since those are pretty big. But yeah, I'll show the work, but it might be sped up here. Okay, let's take a closer look at what we just cleaned up. We can see these two terminals now, here and here, should have enough space. There is actually space underneath these two wires now, but there was a hook connecting those 2 points, this guy, that is actually pretty thick for the space. And those two terminals need to be shorted together, basically as a way to short the two negative sides together of these. It looked like the last one was left in place for the original capacitors, not the ones we just pulled out. So I'm just going to take one of these legs and then connect those 2 points together. But we basically cleaned out the leftovers that were left behind from the last person that did this job, which is not too uncommon, but gives us more space, tidies it up. Why not leave it better for the next person? Okay, so installing the new guys, I'm going to put the one that's furthest back in first, but we are going to use the second one as the jumper, so only one thing has to go through that more crowded terminal. So this guy will just go through here. It looks like it will take a little bit of a bend. Now when you're bending these, be very careful to not put too much strain on this junction point. You can rip the legs out of these things or break it at that terminal. So yeah, we'll instead give like a little bit of a pre-bend right around where we're going to need it to then get this in place. Okay.
Turn these down a little bit.
Okay, so that one's in place, ready to be soldered. So you can see about how much I've trimmed off there from the leads. We'll feed this through the front first. Get our wire here back in place. And I'm going to bend this up and out of the way. You can see our new date code is a 24. So these were made in 2024 instead of 2003. And then let's see, how do we want to do this? We may actually need to feed in from the other side first. Okay, and now we need this negative leg to hook back over and go through. No problem. Sorry, I know my hand is right in the way here, but we've got it going through that terminal and then back over. And then we're just going to tidy it just the slightest bit. Otherwise, we are ready to solder. Okay. Got these two cables still going to place. Those guys are good. All right, so next time someone says point-to-point amps are easy to work on, go ahead and show them this versus replacing caps in a vintage fender. I'm going to solder these guys up and we'll move on to the can cap. And we're getting a big solder ball down at the bottom of the terminal. So I'm going to clean that up real quick. Okay, last up is the can cap. Now these are a little different. We can take a look at how this is on the chassis, but basically it's going to go in this way. And then these outer terminals get twisted once they're inside. And they not only act as a sort of strain relief for holding the can cap in place, but they also connect to ground. So there are solder connections to some of them. Let's take a look at what that looks like currently in the amp. So this is the underside of it, and you can see we have this black wire and this resistor leg going to one of those outer terminals, and the other guys you can see here are twisted and kind of broken off. Now we also have this cap going across the two terminals. You can see the square is acting as an indicator for the side, the orientation. There's a triangle here. On that side, we have those same markings on our new capacitor. And then we have a red wire going to each side. This other same size, flame-proof metal oxide resistor going to that terminal. Okay, so this will take slightly more work to remove, but, you know, we'll walk through it. We really don't need to remove this resistor, since we're going to replace both these probably. Yeah, I may measure once it's removed, see if we need to remove this one or not. It doesn't look heat damaged. If it was discolored at all, we would want to replace it. But let's just go ahead and dive in. Okay, since the solder terminals are on the actual component, we don't need to clean this one up in the same way. We just need to make sure that we pull the components we're interested in out of the way. So, for example, we need to get these wires out of the way. Okay, so we're going to pull this wire out of the way. This one is red with like a gray stripe. Okay. And then we'll want to remove this resistor. We may keep this resistor, so I'm going to try to make sure we don't damage it. Let's see. Looks like it is hooked around here. Oh, sorry about the wobble. Okay. And before we remove that other red wire, I'm going to go ahead and just hook this guy over here so that it doesn't get confused with this second red wire here. Okay. Just taking a closer look at what we've got going on. There's two black wires going to one side there as well. So we'll get these guys out of the way. These are all things that when you're building an amp go together pretty easy, or say, you know, for these terminal stripped areas, if you're building these off outside of the chassis, this is great. But for service, it's a little bit less ideal than, say, a Fender style tag board or a Marshall style early 73 and before, where you have the tag board or the turret board. Okay, we have one last connection point here. Let's get this other red wire out of the way so I don't end up scorching that. I'll just hook it through something. Sure. Okay. There we go. Now I should be able to straighten out or clip these connectors. May end up having to clip the ones that still have solder on them. I don't know if they'll fit through there. Here's the old one. We can see 100, 100 at 500 volts DC. See manufacturing, again, made in, I believe, 01. So this is a 24-year-old cap. New guy going in, 100, 100 at 500 volts. Made in 24. Oh, sorry. So this was made in 04. But 2024 is much better for our needs. Okay. So maybe I'll go ahead and solder the resistor in place. Actually, I think I'll leave it. I'll do it all together. And we want to make sure we're putting this in the same orientation. Let's see. I think I left a little solder on here when I was removing the old guy. Yeah. Okay, that should be good. So what I'm going to do is go ahead and twist these two that have no connections, just to help keep us in place. Oh. Okay, so we are nice and secure from twisting these four terminals. So now I'm going to start from the back and move my way forward, since I'm soldering coming in from this side. But first I'll measure this resistor and make sure we're within spec. I believe it should be a 10K. And we're sitting at 9.92K, so that's going to be fine. I'm going to leave this guy in place. Although, while we're in here, why not? I've got them. Hold on, I'll go grab some resistors. Okay, so let's finish this up before I forget where everything goes. If you've been watching the channel, you would know that I normally make little cheat sheets for this on where wires end up going, just so I don't accidentally get distracted or walk away. Okay, so we're going to start with the hardest to get to point, which is going to be right down here. We need that black wire and that resistor leg to go in there. And let's see if we can get them in place without having to remove more of the solder from those points. So it should just go right through there. We lucked out. Okay. Now that resistor has just the tiniest bit of heat shrink tubing on it to insulate it from ground there, from the chassis. I'm going to lift it up just a little bit. I think we have just enough space there to get that soldered, which is nice. See how secure of a connection that is. Okay, that seems pretty good. The next worst spot is going to be these two ground cables going to the other ground lug here. So we're going to do those, and then we'll probably connect our red wires and resistor to those points, and then add in our new resistor here as well. Okay. I'm going to try to work just a little bit of the solder off these wires. Okay, and these are going to be, as is, slightly too large of a diameter. So let's see if we can split them up. Okay, there we go. I'm doing it this way to save having to trim the cable to maintain its length for future service. Otherwise, we could just clip the end of this off. Which, if it's really bad, is fine to do. You just don't want to end up in a situation where all of a sudden a cable is strained just because you wanted a fresh lead to work with. Okay. We may need to do that here. Yeah, I think maybe we will. Let's see. Try one more thing of getting this guy in first. Now, the other thing to consider is I wonder if we could just go to one of these other ground points. They should all be common. Let's see. Okay, I'm just going to clip these and get fresh leads to work with. Okay, so I ended up trimming the leads for those two guys. Even with that, it was a pretty tight fit. Basically, that was just a way to have leads that didn't have the volume of solder on them as well, to fit through that space in the pin. Okay, now we're going to replace the two resistors. So I'm going to go ahead and prep the one similar to on the old cap. Both of these should be 10Ks. And one of them will go across these two terminals, and then this guy will go from there to there. I'll go ahead and get that prepped and then soldered in place. Okay, so we have our new resistor there in place. These guys are, let me double check the schematic, I believe 2 waters. But let's double check that. Yep, 10K 2 watt. We use metal oxide in these scenarios because they're flame proof, but then also they actually maintain their resistance better under high heat. So let's go ahead and get our red wire back in place. We don't want to forget about this guy. That could be bad. So that one's going to go here. Oh, if I can get it. Okay, and I might go ahead and just solder this in place to help hold that resistor vertical as we get the other guy going on the other side. I'm just gonna get this guy back up where we want it. And hold in place while the solder cools. Sometimes it can be useful to just tack solder or something like this in place just momentarily until you can get a good solder for the other side and then go back and redo the first point that you tack soldered in place. That actually looks like a decent connection, so we'll probably leave it. Okay. And now to that other node, we're going to have the other side of this resistor that we're going to replace, and then our red wire. And those are nice big open junction points, so that should not be a problem. And then we'll be done with our cap job on a Sunn Model T. Not a bad way to spend a Sunday. Okay. So again, you can see this guy's got a real tight wrap. So we may want to just push this through if we can. Maybe too tight for that though, even. Okay, so in these cases, I'm going to clean some solder out of there first. Now we can get a better view of what's going on. It looks like this is the, like you can see they did a full wrap of that leg. This is exactly what I was saying to try to avoid doing. Wherever possible. So then you have to work it loose with your soldering iron, and it's easy to burn something else. Okay, but we got it. So what they did there was let's see, that hook went all the way around as a full circle around the terminal, which we don't want. We just want to do like a half circle at most. Okay. Now this wire is going to go back in here. You can see we've got a little jumper between here and the next terminal over. That's all okay. And we're going to take this resistor. Let's actually trim down that lead a little bit. We need to get this wire in place a little better first. And again, maybe there's just enough length there that I was considering giving it a fresh start like we did with the other guys, but I think in this case, it's short enough already. I don't really want to do that. We will, however, go ahead and trim this other side just barely. Sorry for all the excess noise. I seem to be throwing my tools around quite a bit today for some reason. Okay. Oh. Let's try to keep the camera stable here. Now, what we want to be very careful of is all of these nodes are ground. This resistor leg is going to be connecting to plate voltage, or even higher, actually. So we want to make sure it's sitting above these terminals. So maybe what we should do is hook that first. Okay. I'm going to kind of float it up above a little more and do a nice half crease there. Okay, we got plenty of room now. So I'll solder this up and then give you a closer look. In my attempts to give you a closer view with the camera a little bit lower, I seem to be knocking it all over the place. So I apologize if I'm making anyone seasick here. But someday, as this channel continues to grow, I will be able to throw some money at a dedicated camera for this purpose that has a zoom lens. Oh, and you know what we forgot to do? Let's hook back up the actual cable. Okay. Let's actually get the needle nose on this. And we can probably, I think these terminals have enough space. Maybe I'll just ease this guy right in. Maybe not. All right, I'll pull the solder there. I don't know if it is something that's gained with experience on these kind of things, but you can typically tell when you're doing something the wrong way. And at those times, there is a feeling of wanting to just push through to get it done, but it can be important to step back and recognize that doing something the right way is better in the long run. Even if it takes a little more time. All right, there we go. So that is better. Okay, and now we can clip one more little excess leg from this resistor. And everything is back in place. Okay, so let's take a closer look. So we have new resistor here going to the node for the plates. This is the source of the plate voltage for one side. This is a new resistor. We have this connection. We have our two ground wires that were here. We have this wire going to the other side of the resistor. We have the ground wire and resistor here connected. We replaced the two Sprague Atom 600 volt 20 microfarad capacitors. And we replaced the two electrolytic small signal caps in the preamp. Okay, so this guy's getting closer. next week, we will redo the work here because we're going to be changing the tube sockets. That is going to be no small feat. We're going to have to drill out the rivets for these guys. So that'll be a little bit of an experience. And then this thing will essentially be completely rebuilt with the exception of the preamp at that point. So definitely get some sound samples. Have some fun. All right. As always, thanks for watching another Sunn Day Service. We'll see you next time.